So we were taking whatever this number underneath was, so let's say 120. Okay? We're taking 120 and we're going to break it down into its prime factors, correct? So what is a number that divides 120? 12 and 10? That works. Okay? Both those are still composite, so now we got to do the same thing with 12. What's 12 break down to? 6 and 2, that's fine. What kind of number is 2? Prime. Okay, so I'm going to stop with the 2. 6 is composite though, right? What's going to? 3 and 2. Okay? Come back and look at the 10. 10 goes down to 5 and 2. Okay? So now all these branches are terminating at prime numbers. So what we're going to say here then is that radical 120 is the same thing. There's multiple ways of writing this, but radical 120 is the same as, we've got how many 2's? 3 2's, so 2 times 2 times 2. We have, what, 1 3 and 1 5, right? Okay. We also said that that is equivalent to this. Is that okay? Okay. Now we said that that is actually taking care of those two things. Does that make sense? Okay, so what is 2 times 2? 4. So this is really radical 4 right here. Does that make sense, everybody? But what is radical 4 the same as? Radical 4 is the same thing as 2, right? Square root of 4 is 2. Okay? Now, this does not have a pair, that does not have a pair, and that does not have a pair. So they all get multiplied back together underneath, right? And then we get 2 times radical 30. And that's a simplified version of radical 120. Okay? Now we can use whatever calculator we prefer and just take square root of 1. Very few calculators will actually tell you, like I type in radical 120 and it give you back 2 radical 30. But we can do the work by hand, type in radical 120 here, and type in 2 radical 30. And because the decimals end up being the same, it tells me that these two things are the same. Does that make sense? Okay. The only thing this does not tell me is whether that 2 radical 30 is fully simplified. Because we might come across something about fractions. If I think about a fraction like 10 over 20, can I reduce it to 5 over 10? Is 10 over 20 reduced to 5 over 10? It does, right? Is it fully simplified though? No. So it could go one step further to 1 over 2, correct? So same thing can happen with radicals. Okay, so using my calculator here just confirms that 2 radical 30 is the same thing as radical 120, but it does not confirm that basically the radical 30 is simplified. This process does, though, okay, if we understand this process. Okay. We also said that we could rewrite, and this is where we kind of ended on Wednesday last week, that we could rewrite this here as 2 cubed times 3 times 5, right? 2 times 2 times 2 can be repetitive multiplication, can be rewritten using exponents. Now, in that format, it might not be all that useful, so we talked about how we could do this. 2 to the third is the same thing as 2 squared times 2 to the first times 3 times 5. And if we break that apart into their own radicals, we talked on Wednesday that that radical and that power of 2 undo each other, right? We went through, I think we did it on Desmos here, where if I say I'm going to take the square root of like a squared, no matter what I make a, as long as it's a positive number in this situation, no matter what I make A, when it puts it in here, do I get back 3.6? Does that make sense? So really what is going in right there for that thing right there is actually that number right there. So right now I'm taking the square root of 12.96, okay? But because it can be written as 3.6 squared, the square root and the power of 2 cancel each other out, and all I'm left with is 3.6. Okay, so that's the idea of square roots and powers of 2 being inverses of one another. They undo each other. Okay, so we can then use, it's a what we call a cancellation concept. We can cancel the radical with the power, and you're left with just the 2 then. Okay, and that's the logic on why when we come back up to here, you remember last week we said we're going to circle groups of 2, and that's what comes out in front of the radical sign. Well, the reason we're doing that is because that group of 2 right there is this 2 squared or this 4 right here. And that basically tells us that 4 is the largest perfect square that divides 120. Okay? 4 is the largest perfect square that divides 120. That's what we're doing when we simplify radicals. Okay? So, the next step in working with radicals is to talk now about fractions underneath a radical. Okay? So let's say that we have, let's just say for now, radical 120 over 75. Okay? And there's going to be a lot of, eventually, there might be several days that we spend on this concept because once we simplify this, there's going to be another step that we haven't learned yet that needs to be added on to the end. Okay? But what I want to do right now is just take this fraction, and I want you guys to know that when it's a radical with a fraction underneath, you can separate it to this. Okay? Remember saying that the product underneath a radical, each one of those factors can be put underneath their own radical? Same thing happens with a quotient. Okay? The numerator can be put under its own radical, the denominator can be put under its own radical. Okay? And now what we're going to do is we're going to view the top as a separate problem and view the bottom as a separate problem. Okay? So the top, we've already done that one. I'm not going to spend time factoring that one again. We know that that's 2 radical 30, correct? Okay? The bottom one, we're going to have to go to the side and say, okay, radical 75, what are 2 numbers that divide 75? What are the first 2 numbers that come to mind when you see 75? It'd be 5 times 15. That works. That's the first thing that comes to mind now? 15 nickels comes to mind? 3/4, right? That's what comes to mind most people, I would think. So 3 and 25, right? Okay, so last week we said we could stop there if we wanted to. If you're vigilant about identifying the types of numbers you have here, what kind of number is 3? Prime, what kind of number is 25? Perfect square. So what we're seeing here is that radical 75 can be written as radical 3 times radical 25. But what's radical 25? 5. So I'm going to change that to 5 and then times my radical 3. So 5 radical 3. Okay? If you weren't paying attention to that, could you still take that 25, break it down to 5 and 5? There's your group of 5s that can come out in front of your radical. And this 3 doesn't have a group to go with, so it goes underneath the radical. Does that make sense? This thing here, then, that is equivalent to radical 120 over 75. Let's double check. So square root of 120 over 75 gives me that number there. If we go 2 times the square root of 30, all of that divided by 5 times the square root of 3. Same two decimals, so that means that there is the same as that. Okay? Now, eventually, we will not like this. Okay? I'm not going to get into it too much today, but we don't like radicals in the denominator. Okay? So what we will do is a process called rationalizing the denominator. I'll just kind of show you what this would look like. We actually multiply it by that radical. So top and the bottom. If I multiply the bottom and the top by radical 3, what did I really just multiply by? I multiply by radical 3 over radical 3. I multiply by 1, right? That's just a convenient form of 1. But what that does, and we haven't talked about this too much, but when I multiply radicals, the numbers that are on the outside get multiplied together. Numbers on the inside get multiplied together. So it gives me 2 radical 90. On the bottom, it gives me 5 radical 9. And what's radical 9 the same as? Close. You said radical 3, right? Take the radical off. So it's just 3, okay? So I get 5 times 3 on the bottom. So the bottom becomes 15. The top, now I got a new number, 90. Well, what are two numbers that multiply together to give me 90? 9 and 10. 9 goes to 3 and 3, right? 10 goes to 2 and 5. There's a group of 3s. So the top, that 2 stays, but the 90 turns into 3 radical 10. Okay? Would you guys agree that there is a 3 up top and there's a 3 in this 15 down here? I'm going to take that out, make it a 5. So we get 2 radical 10 over 5. Okay, now I know that's a lot of work and that's messy, and we'll get there at some point. But what I want to demonstrate is that initially we had 2 radical 30 over 5 radical, is it 3? That was one format. Would you guys agree that this looks simpler? Okay, well think about this. Is the radical here 30, and this one's 10, right? Is 10 a simpler number than 30? Yeah, okay. This is an irrational number down here. Okay, it's a product of two numbers. This is a rational number. Is 5 simpler than that number right there? So we eventually prefer that right there. And to convince us that that is the same, if I go to radical 10, divide that by 5, is it the same value as these others? But that's the preferred version over these other two. Okay, and we'll get to being able to do that, but it's going to take some time and some practice. Yes? You will have, so they will ask you, I think the way it's set up is that they're going to be smaller numbers than 120, 75. I think the way it's set up is that once you get to this right here, you should be fine. If not, once you run through it, we can work together in class to get back down to this here. But this is the end game right here. That's the end goal over the next couple days to be able to get to that point. That make sense? Okay. Let's see here. Let's do another one. Okay, so answering Maya's question about, how's the homework going to look? One of the homework questions is something like this. So not 120 and not 75, right? More kind of toned down a little bit here in regards to the size of these numbers and how composite they are. Well, the first thing you're going to do is exactly what we did. We're going to take the top and rewrite it in its own radical. We're going to take the bottom and rewrite it in its own radical. And then we start simplifying. Okay, what is the square root of 1? This is maybe one we haven't talked about too much, but remember, this is a symbol. This is a symbol for some number that when I multiply it by itself, I get 1. What is the only number that you can multiply by itself so that you get 1? 1. So square root of 1 is 1. What is the square root of 4? 2. So radical 1/4 is the same thing as 1/2. And see if that makes sense. So radical 1/4 is a symbol. So this here is a symbol for that number. Okay? Meaning that when I take 1/2 times itself, I should get 1/4. I should get the radicand. What's 1 times 1? 1. What's 2 times 2? 4. Okay? Maybe we'll see something like radical 4/9. Okay, so again, take the top, turns into radical 4. Bottom turns into radical 9, right? What's the square root of 4? 2. What's the square root of 9? 3. So you'll type in 2/3. Okay? Let's see here. Let's go radical 108 over 121. Okay. I believe the way from just going through on the side here, looking at your homework, I believe your homework, the denominator is always going to, initially today, going to be a perfect square. Okay. Which is nice. But you might not recognize your perfect squares right off the bat. So what we would do is we would take and rewrite this as radical 108 and radical 121, right? So now take your 108. What are two numbers that multiply together to give me 108? $12 and 9? That is a quality answer. I would have gone 2 and 54. But it's pretty impressive that you see 12 and 9 there. Can I stop with 9? I could. Why? Perfect square. Let's just keep going with 3 and 3. What about 12? 4 and 3? 6 and 2? That would have worked too. And then 4 goes to 2 and 2. All right, so there's a group of 2's that can come out of my radical, right? There's a group of 3's that can come out of my radical, correct? And that 3 is left all alone, staying underneath. So I get 6 radical 3, right? That's the same thing as radical 108. The bottom, 121. So maybe we take 121. Okay. Anybody know 11 and 11? Okay. Those are the only two factors. It's kind of a unique perfect square because its two factors are odd numbers, okay? Which are not just that they're odd, but they're prime numbers. Does that make sense? So, like if I had like 144, that's a perfect square as well. But that goes to 12 and 12. You could have chose 36 and 4, 72 and 2. So that is a perfect square, but its factors are all composite. 121 is kind of rare because its factors are both prime. But nonetheless, that's a group of 11s, right? They come out of the radical. Now, is there anything left to go underneath the radical? No, so the radical just disappears. Okay? So then, that 11 on the bottom. Okay? The only thing that I think would be important to look at here, so let's go ahead and draw the comparison. Let's just double check real quick. I think you guys should do this. Square root of 108 over 121. Is that the same thing as, what did we say at top was? 6 radical 3? Okay, just double check to make sure they're the same. Let's do radical 108 again over, let's go 144. So radical 108, we've already done. So it gives us 6 radical 3, correct? What's 144 break down to? It's just the speakers on my computer are connected to the projector. And it's really loud right now. 144? 12 and 12? Okay, can I stop there? Because it's 144. If it's 12 and 12, does that mean it's 12 squared? And will that radical and that power 2 cancel out? And I get 12, right? Okay, if you don't realize that, you keep going. 12 goes down to 6 and 2. And then 6 goes down to 3 and 2. So now I've got 2 3s and 4 2s, right? So 2 times 2 times 2 times 2 times 3 times 3. Is that a group of 2s? Comes out of the radical, right? Is that a group of 2s? Comes out of the radical, right? Is that a group of 3s? Comes out of the radical, right? What's 2 times 2? Times 3? It's the same thing as that. So we get 12 here. Okay? Now, here's the difference in this question compared to the last one. Is there a common factor in the top along with the bottom? Is there something that will cancel here? 2's. Okay, so remember that this 6 is 2 times 3, and we've got our radical 3, right? So I can actually do that. And then this 12 is 2 times 3 times 2 again, right? Right that way. That make sense, everybody? So what is, and you usually wouldn't write it this way, but what is 2 divided by 2? It's just 1, right? Okay. What is 3 divided by 3? It's just 1. So these two things cancel each other out. And I say cancel through division, it just turns into 1. So all I'm left with is radical 3 over 2. Because this 6 and that 12, they share a factor of 2 and they share a factor of 3. Does that kind of make sense? And just to double check that, if I take radical 3 divided by radical 2, or not radical, just 2, so radical 3 divided by 2, I think it's going to be like 0.707. No, 0.866. If we go square root, what do we have? 108 divided by 144, same 0.866 now. Okay. That becomes a very important radical eventually in working in trigonometry. Is that something we can do? Okay. So that's working with fractions. I want to do one more. I think. Let's do a simple. And this is going to be kind of it's the first question on your homework, but it's going to be what kind of segues us into tomorrow's topic. If I have 12 times x to the 11th, and that's all underneath the radical, okay, I want to be able to simplify that, okay? So when you start getting variable terms under your radical, the first thing that you guys are going to want to do is separate the number portion and the variable portion. I think that's the safest thing to do. And it essentially breaks it down to 2 problems for us. We can now take the 12, and we're going to simplify the 12. So the 12 turns into, we've done 3 and 4, 2 and 2, right? So the 12, if I make my radical, this 2 can come out. That 3 stays underneath. Okay? Now, so we've attacked that. We're done with that. We need to attack the x to the 11th. We kind of hit on this last Wednesday, but x to the 11th, like if I take like a times a, and those both have exponents are 1, right? What do I get when I take a times a? A squared, correct? We add the exponents, correct? Okay, so if this was a to the 3rd times a to the 1st, you'd write this as a to the 4th, right? You'd add those exponents. So right now, what we've really got here is a product of a bunch of x's. So we basically got like this a to the 4th here. And I want to go backwards and say, okay, what can I have written that as? Will you guys agree that x to the 11th can be rewritten as x to the 10th times x to the 1st? If I multiply those, and I add the exponents, that still give me 11? Okay, so here's what we're going to do now. We're going to put those both underneath the radical. And what happens when you have an even power, that square root and that power are going to cancel and cut the power in half. So what's half of 10? 5. So that gives me x to the 5th. Okay? And the reason for that is because x to the 10th can be rewritten this way. X squared times x squared times x squared times x squared times x squared, right? Adding the exponents, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So that's x to the 10th. If I put them all underneath the radical, doesn't that cancel, 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 cancel? And you're left with just the radicand of x times x times x times x times x. How many x's you got there? 5 of them. It's multiplied. It's repetitive multiplication, so we use powers, right? So x to the 10th underneath the radical is x to the 5th. That comes out front with your 2. This x, the radical did not cancel because that number was odd, right? Okay, and we're going to try to do this every time to where that number is always going to be a 1. So that stays underneath. So we get 2x to the 5th times radical 3x is the same thing as that. Okay? Now, we can check this on our calculator as well. I think maybe if you're going to use x, the scientific version of the calculator is the best. Now, it doesn't know, like if I type in square root of 12x to the 11th, it's going to not know what to do. If I highlight that, it's going to say too many variables. Okay? I'm okay with that right now. We said that that should also be equivalent to 2x to the 5th times the square root of 3x, right? Again, it tells me try to define x. So give me a number for x. Everybody but Austin. 3. Okay, so if I put 3 in, does that give me these two numbers to be the same? Okay, so that tells me that these two things are the same, right? If I plug 31 in, are these two numbers the same? So that means these two things are the same. Okay, so when I plug 3 in, really what I'm plugging in underneath that first radical right here is 12 times 3 to the 11th. We're actually taking the square root of that number right there. Okay, does that make sense? So we'll pick up with that tomorrow. Lead off with that. We'll do more examples with variables underneath the radical.